Okay, in this video we want to introduce ordinary generating functions and try and solve some very simple problems with them so that we sort of get an understanding of what ordinary generating functions are, how they work, and then in the future videos we'll try to solve some more complicated problems using the approach of generating functions. And just to introduce them, suppose that we just had a sequence. It could be a sequence of numbers, say, like this, and so forth. And a generating function that we could make with these sequence of numbers can just be something very simple. Instead of f of x, we'll call it g of x for a generating function. The first term can be just simply some constant plus a1 or a sub 1 times x plus a sub 2 times x squared plus a3 times x cubed plus a sub 4 times x to the fourth power, and it can keep going like that all the way to infinity. For example, let's say that we just had the sequence of numbers, just a series of ones. Then the generating function, we say that the first number is a constant. Well, 1 is a constant, so we could have a 1 there, plus, okay, our a sub 1, all these numbers now, they just correspond to 1. So we're going to have 1 plus x plus x squared plus x cubed plus x to the fourth, and that would go all the way to infinity. Now, if you remember what a geometric series is, you might realize, well, this is the same thing as 1 over 1 minus x, providing that x, the absolute value of x, is less than 1. So that's fine. If we have a series of numbers like 1, and we want to multiply them by these x's raised to various powers, and we want to do it with x's so that the absolute value of x is less than 1, doesn't matter. So there would be a very simple sequence of numbers, and here would be its corresponding generating function. Or suppose we had, say 1, and then negative 1, and then positive 1, negative 1, positive 1, and so forth. So now the generating function starts off with a constant. So the constant can be 1 if we want to. Then here now, this is negative 1, this is plus 1, this corresponds to negative 1, this corresponds to plus 1, so the generating function that we get is 1 minus x plus x squared minus x cubed plus x to the fourth, and the pattern keeps repeating itself. And incidentally, this is equal to 1 over 1 plus x. Again, for values of x that are absolute value of x less than 1. And we can, without loss of generality, say, yes, for our generating functions, we would like to work with x's that are where the absolute value of x is less than 1. We can have that stipulation without any loss of generality. So this is just kind of an introduction as to what generating functions are, or at least the ordinary generating functions. Now, what makes them interesting and useful for us is that when you have a generating function, and let's say that we have x to the n in the term here multiplied by some coefficient, well, what makes the generating functions useful is that the coefficient of x to the n, we'll just say a sub n, whatever number that is, that number, that coefficient, it turns out that that represents the number of ways to choose n items, so that when we're choosing them, the order is irrelevant. And to kind of get an idea as to why that holds up like that, let's just say that we had 3 different objects, say A, B, and C. Now, we know that how many ways can we select one object? Well, there's 3 ways. We could choose an A, a B, or C. Again, the order doesn't matter, so if we decide to choose CBA or CAB, the order doesn't matter, so all these are the same. So the number of ways to choose one object is 3. So there are 3 ways to select one object. Okay, suppose you want to select 2 objects, and again the order doesn't matter. How many different ways can we do that? Well, we can see we could choose AB, we could choose BC, we could choose CA. Now the order doesn't matter, so if we decide that we're going to choose BA, well, these are the same, and of course CB, these are the same, AC, these are the same. So when the order doesn't matter, then there are 3 ways to select 2 objects. Three ways to select 2 objects. Now before, in our earlier videos, when we started work with combinations, we said, well, if there's 3 objects and we want to choose one of them, and the order doesn't matter, how many ways can you do it? That was just this. Or of course it was just this. Now, how many ways can we select 3 objects when the order doesn't matter? Well, of course, we could have A, B, C, and that's it, because we said, well, yeah, we could have BAC, but the order doesn't matter, so this is the same as that. Or we could have CBA. It doesn't matter, because the order is irrelevant, so there's one way to select 3 objects. And of course, before, we would have said, well, of course, if you wanted to select 3 objects, from 3 objects it would be this, and of course this equals 3, this equals 3, this equals 1, so there's no surprise here. But let's relate this now to generating functions. Suppose that, let's see how it's done. Suppose we have 1 plus x times 1 plus x times 1 plus x. If you multiply that out, this equals 1 plus 3x plus 3x squared plus x cubed. Now, we'll talk about this side of the equation in just a moment, but let's look at this side of the equation. The exponent on x is 2, and we just finished saying that, yes, if we have three different objects, A, B, C, and we're going to select two of them where the order doesn't matter, there's three ways of doing that. And sure enough, the coefficient on x squared is 3. How many ways can we select one object? 3 different ways. Here we have x to the first power, and its coefficient is 3. How many ways can we select 3 objects where the order doesn't matter? And we said, well, there's only one way. And sure enough, the coefficient on x cubed is 1. How many ways can we select 0 objects? Well, that would be the coefficient of x to the 0, and of course, that's 1. There's only one way that you could select 0 objects. So, what do these mean? Here then, we can think of this as a generating function for the object A, and this means that, well, for object A, we may choose 0, or we may choose 1. The exponent here on x is 1. The exponent here we can think as x to the 0, so we may choose 0 A's or 1 A. We may choose 0 B's or 1 B. We may choose 0 C's or 1 C. So you can think of them that this is sort of the generating function for the object A, and that we have two choices. We don't select A, or we do select A. And the identical generating function holds up for object B and for object C. Now if we say, well, let's consider all 3 objects. How many ways can we select 1 or 2 or 3 or none? The way to find that is by multiplying all the individual generating functions together, which we did, and then we look at the coefficients of x raised to different powers. So again, if we're selecting 2 objects where the order doesn't matter, we say, well, the coefficient of x squared is 3, so there must be 3 ways to do that. So let's just consider a very simple problem. We'll do it both ways. The ways that we did it in the past videos is thinking in terms of combination, and then how we can also solve the problem using generating functions. So let's say, for example, suppose that a committee is comprised of 50 members. And 6 members, so we're going to choose 6 members at random. To form a public relations group. Okay. How many ways can we do this, assuming that the order in which the members are chosen is irrelevant? Well, if you looked at our past videos when we were solving different types of permutations and combination problems, we said, well, it'd be this. Or we would have to determine what this binomial coefficient is equal to. Whatever that number is equal to, that would be the number of ways that we could do it. And that's true. Now let's think of it in terms of generating functions. There are 50 members, and for each member, they may be selected or they may not be selected. So for each member, we can think of an individual generating function of 1 plus x. That particular person may not be chosen, or they may be chosen once. The next individual Same rule applies. The next individual may not be chosen, or they might be chosen once. Same thing for the next individual. May not be chosen, or might be chosen once. And we would do this then for all 50 of them. And we multiply all these individual generating functions together, we get to the 50th power. So this right here, that would be the generating function then of selecting 6 individuals out of 50 individuals when the order doesn't matter. But it's not just this. We have to consider, okay, we have this, and that was obtained simply by multiplying all the individual generating functions together, just like we did when we had the 3 objects, A, B, and C. This is 50. But now what we have to do is, when this is multiplied together 50 times, or when we have 1 plus x to the 50th power, what we're interested in is the coefficient of x to the 6th, because whatever number that is times x to the 6th, that is the number of ways in which not one person is chosen, but the number of ways in which 6 people can be chosen. So now is when we're going to use our knowledge from the previous videos when we were dealing with the binomial theorem, because we know this. That is equal to it's a very simple expression. And it just keeps going like this. So for x to the 6th, its coefficient is just simply the binomial coefficient, 50 over 6. And of course, that's exactly what we said when we set the problem up initially. Think of it in the classical way, if you will, that yes, if you have 50 members and you're going to choose 6 of them at random, the number of ways that can be done, assuming that the order doesn't matter, is this. Now, and again, we just chose a very simple problem to illustrate the point. Here then what we do is, for each individual member, we can think of, for each individual member, there's a very simple generating function. It's 1 plus x. That person is not going to be chosen, or they're going to select them once. And that's the same for every single of the 50 members. And like we said just earlier when we were dealing with the objects A, B, and C, if you want to consider how we can choose from among all 50 members, then it's all 50 of these multiplied together to give us this. Then we're interested in how many different ways can we select 6 members, and that then is the coefficient of x to the 6th, which of course is just this. But again, we chose this problem just for to give a simple explanation of how we can use a generating function to solve a simple problem. Think of it like this, and then how do we find the coefficient of x to the 6th? Okay, in the next video, we're going to solve 2 more simple problems using the technique of ordinary generating functions, and then we'll have a slightly more complicated problem. And then after that, we're going to consider some of the more complicated ordinary generating functions. And by the way, if you just found us on YouTube, if you will go to the website, all the videos that we have concerning combinations and permutations and probability, if you go to the website, you'll find all of the videos there are presented for you in their proper sequence. Okay, that's it for this video. Come back and join us for some more videos, and we'll try and solve some more problems.